Now that we have a solid understanding of DeLauney's triangulation, we're going to finish off this series with some practical key takeaways. We will cover two areas, modeling considerations and cross-platform interoperability considerations. When building proposed templates, the modeler needs to be aware of which points and their subsequent break lines will be necessary to accurately represent a top, bottom, or any intermediate surface of your design. This can become more complicated when you have multiple models and templates that are all combined at the end to create a single proposed surface. Template points and components must have some nominal slope to avoid any vertical faces or overhangs. Further, in open roads, not only do we have the traditional templates that we drop at intervals along our alignment, but we also have the unique ability to apply templates vertically to any terrain element. This allows the modeler to apply multiple components to give either a depth or a height to a surface model. Surface templates are a very powerful tool for modeling the pavement sections of irregular areas like parking lots, driveway aprons, or intersections. That said, because surface templates are applied to a terrain vertically, the resulting break lines will be perfectly vertical. Thus, surface templates nearly always result in break lines that are not DeLauney's compliant in these detailed modeling areas. What this means is that the modeler will need to go back and add additional 3D line work that can be included in the terrains in lieu of break lines created from the template points. In the case of surface templates, this additional break line information is most often required for the bottom surfaces. In the previous videos, when discussing DeLauney's, we only considered points or spot elevations to help simplify the explanation. But there are in fact several other feature types that can be included in a terrain. Some of these feature types may be universally supported in other software, like break lines, boundaries, voids, etc. Whereas more exotic feature types, like contours, soft break lines, islands, may not be supported in other applications, or these feature types may not be processed in the exact same way that they are in open roads. This can lead to a much different triangulation result in other software. While DeLauney's is very consistent between software when we look at points or even break lines, these more unique feature types do not always offer the same consistency, so it is important to bear this in mind when delivering terrains to others. Lastly, edits made to terrains like the deletion of triangles, flipping of sides, or other minor adjustments are not retained when you retriangulate or reprocess the surface from features in open roads or any other software. If you have a lot of post-triangulation edits like this, you may want to consider delivering the surface in a common CAD format that has graphically static triangle geometry, which can be imported into a new surface as break lines. In this video series, we've discussed the fundamentals of how DeLauney's is applied to data to create terrain elements. It should be clear by now that the limitations of this methodology are very important for the modeler to master, as it directly impacts the success of project delivery. By now, it should also be clear that DeLauney's is not something you can afford to consider after the project modeling is substantially complete. Rather, from the very beginning, the entire modeling team needs to be on the same page about what final surface models are required to be delivered. Before your team begins modeling, it is important to plan out how the project will be broken up, who will be responsible for each model piece, and finally, how best to set up all templates so that the final surface models are DeLauney's compliant when all of the modeling is brought together.